Zoe, this is my physics lab 4. Okay, so introduction. In this lab, we measured the distance dependence of the magnitude field due to a small bar magnet and compared the measurements to the distance dependence predicted by the equations for the on and off magnetic fields derived from the Biot-Savart law. That kind of explains the purpose of the lab. And then the result preview is as the magnetometer moved farther from the magnet, the magnetic field strength decreased. Furthermore, the magnetic field along the magnet's axis was stronger compared to the off-axis field. This is supposed to say off. Sorry. Okay, so some important physics principles and models. First is the Biot-Savart law, which is shown here, and it calculates, the purpose of this law is to calculate the magnetic field generated by a steady current, and it's similar to Coulomb's law, but for magnetism. And then this is a figure of magnetic field lines of a bar magnet, and you can see it points from south to north poles. Okay, so getting into the experiment, some materials needed are bar magnet, smartphone, meter stick, magnetometer, ruler or additional meter stick, a few pieces of tape, and then the Excel spreadsheet. And this shows our experimental setup, and it shows the two different setups that we had for this lab. Okay, so some data and observations. So first, when the magnetometer is far away from the magnet, the measured magnetic field in the x direction is near zero, versus as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. And then our figure supports this. If I zoom in a little, you can see as Bx increases as the magnetometer moves closer to the magnet versus it decreases when it's further away. Right. And then, so this is the code, and you can see through this is the snapshot of like when you run the code what happens, and you can see how the on axis is stronger, has a stronger magnitude field compared to the off axis. And yeah, so getting into the code, first is the function for the magnetic field, and you can see that we follow this formula that we talked about previously for the Biot-Savart law. And we create the R magnitude and then R hat, which we've done many times before, and then we kind of follow the formula for the Biot-Savart law. And then we have the scale and distance, and I chose this distance because the middle distances are more data, just for kind of seeing like the best, like more accurate point to use. And so then we edit for the observation locations for on axis, and then we create the arrows to represent magnetic fields. And then for this part, the average Z-perp from our experiment, and we use these values here, and when you average them, you get 0.184 for that. And then we created the observation location at 45 degrees from the axis, and then an arrow to represent the magnetic field, 45 degrees. And you can see how this is a lot smaller compared to the others. And then so question, so what if we hadn't oriented our experiment to compensate for the magnetic north and had instead laid out our meter stick at some intermediate angle with respect to Earth's magnetic field? The magnetic field from the Earth would act on the magnetometer, which would make the slope incorrect. And for 2, if we were to stick 2 identical magnets together and then run the experiment again, then the magnetic moment would double, which will result in the magnetic field roughly doubling since it's proportional, and the possible error is the sensor not being properly aligned when we're doing our experiment. So yeah.